All right, welcome advanced geometry students, Mr. Donaldson. And today I'm coming at you from the classroom. So I'm hoping all of this works the same, kind of have a similar setup to what I was using at home, but just hoping the audio and everything comes across okay. So today we're going to just talk about how we can apply some algebra to what we're learning, and our focus is going to be on writing equations of lines. But before we get there, just a couple reminders of some formulas that we've learned already in this class, or perhaps you learned back in Algebra 1. So first, the distance formula. We use that formula to find the distance between any 2 points in a coordinate plane. The slope formula, we use that to find the slope of any line if you're given 2 points on that line. And then the midpoint formula, we use that to find the midpoint of a line segment when you're given the end points. So here's just a quick little example and how it relates to a transformation, in this case a translation. So suppose that I have a point A prime at 1, 8, and it is the image of point A, which was at 2, -3, after a translation. Find the following. The first one is to find the distance of translation. So remember, by definition, when we're dealing with translation, the distance of a translation is simply the distance from any point in the pre-image to its corresponding point in the image. So all I'm going to do here is use the distance formula, and I'm going to plug in these 2 points. So here we go. I'm going to call this first point, just for reference, x1, y1, and the second point will be x2, y2. So here we go. The distance translation can be found by going the square root of x2 minus x1. So that'd be -2 minus 1 squared plus y2, which is 3, minus y1, which is 8 squared. All right, and we're just going to use some algebra to simplify that. So that's -3. We'll square it in a second. And then 3 minus 8 is -5. We'll square that in a second. Now remember, you guys, when you square negatives, squaring is multiplying by itself. And a negative times a negative is a positive. So that would give me the square root of 9 plus 25, which is equal to the square root of 34. Now, if that was a perfect square, I'd like for you to, actually give me what the value was. So, for instance, if it turned out to be the square root of 36, I'd want you to tell me 6. But in this case, the square root of 34, I like that better than you giving me some sort of decimal. It's better than 5 point something. It's a bit more accurate. So you would say the distance of translation there is the square root of 34. Next, I want to know the slope of the line segment that goes from A prime to A. So to find slope, I'm just going to plug into my slope formula, which is y2 minus y1 on top, so 3 minus 8 on top, and then x2 minus x1 on bottom, which is -2 minus 1 on bottom. So 3 minus 8 is -5, and -2 minus 1 is -3, and as you know, negative divided by a negative is a positive, so we get a slope of positive 5/3. And then the last one there asks for the midpoint of that segment. And as you can see the midpoint formula there, I'm going to scroll down to have more room to do my work. But the midpoint formula is going to average the coordinates. So we'll average the x coordinates, which gives me 1 plus -2 divided by 2. Then we're going to average the y coordinates, which is 8 plus 3 divided by 2. That gives me -1 over 2 is -1/2, comma, 11/2. And I prefer fractions, decimals, so hopefully you'll give me fractions when you come across them. All right, there you go. So now we're going to get into actually the meat of this lesson, which is writing equations of lines. So if I ever ask you to write the equation of a line, there are 2 forms that you should use, or formulas you should plug into to write those equations. Now the first is the slope-intercept form. We practiced this last week, all right? Or actually, I should say last lesson, which was actually last night. So with the slope-intercept form, you're given the slope, you plug in there, and you'll be given a y-intercept b, and you're going to plug in there. And then you have the equation of your line. For point-slope form, we're going to plug in a couple other things, all right? In this case, so both cases you're given a point and a slope, but in the slope-intercept form case, that point happens to be a y-intercept, which makes your life a lot easier. This next one, we're still going to need a slope, m, still going to go in for m. But then you're going to need the x-coordinate, it's going for x1, and the y-coordinate of whatever point you're given to go for y1. We plug those values in, and we just use some algebra to simplify that equation. So the key to this, all right, the most important thing that you understand is anytime I ask you to write the equation of a line, what you need is a point and a slope. Now, if that point happens to be a y-intercept, even better. It's going to make your life a lot easier, and you'll see why in the examples. Anytime you're asked to write the equation of a line, you should just be asking yourself, what point do I know? What slope do I know? So let's get started and take a look at some examples. So the first example says, I want you to write the equation of a line that contains the points 0, -7, and -3, 2. Now you'll notice the two things I need is I need a point and I need a slope. Now, there's 2 points given, right? There's more than enough points given. But I want you to notice, this point is a y-intercept. That's definitely the point I want to use because it's going to make my life easier, and I'll show you why in a second. But I still need to find the slope. So to find the slope, I'm going to use my slope formula. So y2 minus y1, so 2 minus -7, over x2, which is -3, minus x1, which is 0. So my slope is going to be 2 minus -7 is +9, and -3 minus 0 is -3. So my slope here is going to be 9 divided by -3 is simply -3. Now, here's why it was so important in the beginning that I recognized that this was a y-intercept. Because now I can go back and I can use this formula, which is substantially easier to plug into. So check it out. All I'm going to do is plug in my formula, and I get y equals -3x minus 7. All I had to do was plug in my slope of -3, my intercept of -7, and I have my equation. Now in example 2, I'm given a point at 6, -6, and I'm given a slope of -2/3. Now I notice that this point is not a y-intercept. And remember, you recognize a y-intercept when the x-coordinate is 0. And that was the case in that first example. So because this one is not a y-intercept, that means I got to go back and use the point-slope form of the equation. So here's how we plug in. Y minus, here's my point. This is going to be x1 comma y1. So y minus y1, so y minus -6, equals, the slope is -2/3 times x minus x1, which is +6. So all I've done so far is I've plugged in for y1, and x1 in my formula. But now, you guys, I always want your answer when I ask you to write an equation to be in slope-intercept form. So we got to get y all by itself. So to do this, I'm just going to do a little simplification. Minus a -6 is +6. That's easy enough. Now I'm going to distribute. This gives me -2/3 x. And then you guys take a moment to multiply -2/3 times -6/1. I'm going to show my work. I get +12 over 3, which is 4. So I end up here, when I distribute -2/3 times -6, I get +4. And then the last step to get my equation nice and tight and get it in slope-intercept form is I will subtract 6 from both sides. So I end up with y is equal to -2/3 x minus 2. There you have it. A little bit more algebra because we did not have the y-intercept. So you'll notice that first example was a lot easier and quick because I was given a y-intercept. So when you have the choice of points, if you can find a y-intercept, that's really helpful. All right, so now let's get into how we can apply this right equation stuff to geometric concepts. So the first thing I have written here is, remember that parallel lines have the same slope. So if I want you to write the equation of a line parallel to a different line, you know the slope right away. It's got to be the same. The next is perpendicular. Perpendicular lines have opposite reciprocal slopes, which means, for instance, if the slope of one line was 4/5 and I want to write the equation of a line perpendicular to it, opposite means if this is positive, my slope is going to be negative. And reciprocal means you flip that fraction upside down. I used to always say reciprocal when I taught algebra. Just remember, you flip that fraction. There's 3 types of lines, and there could be more, but for now, 3 types of lines I'm going to ask you to write the equation of. One is a perpendicular bisector. A perpendicular bisector is a line that is perpendicular to a segment and intersects at its midpoint. So if you think back to what we need to write the equation of a line, you need a point, so it's going to be the midpoint, and you need a slope. And because it's perpendicular, the slope is going to be the opposite reciprocal of the given line. All right. Next is a median. So I could say, hey, here's a triangle. I want you to write the equation of a line that contains the median. So what you got to know about a median is with the median, you will not be given a slope, but rather you'll be given 2 points on that line. You'll be given one of the vertices of the triangle and the midpoint of the opposite side. And then you will use those 2 points to find the slope. And then the last one I might ask you to find is an altitude. You guys be familiar with these words, okay? An altitude, this is going to go from a vertex of a triangle and perpendicular to the opposite side. So my point will be given to me. It's going to be the vertex of the triangle. And the slope I will find by doing opposite reciprocal because it's perpendicular. So let's do some examples. All right, first, write the equation of the perpendicular bisector of segment AB. So as soon as I read perpendicular bisector, you got to know what that means. And the first thing is, it goes through the midpoint of the segment. So that's the very first order of business I have, is I'm going to find the midpoint of that segment. Now you could use the midpoint formula, no doubt, but when it's graphed, it's almost just as easy to count. Notice, to go from A to B, and go up 1, 2, 3, 4, 5, 6, and I go over 4. Well, halfway there would just be up 3 and over 2. So I can pretty quickly and easily see my midpoint is going to be right there, -2, 1. That's the point I'm going to use when I write my equation. But now I need a slope, all right? So it's a perpendicular bisector, which means that when I want the slope of my line, it's perpendicular to this given segment, so the slope's going to be the opposite reciprocal of that given segment. The slope of segment AB, just by counting, as I go up 1, 2, 3, 4, 5, 6, and I go over 1, 2, 3, 4. Well, 6/4 simplifies to 3/2. So if the slope of that segment is 3/2, then the slope of the line that I'm going to write the equation of would be -2/3, the opposite reciprocal of that. So now I have everything that I need, and now I'm going to write my equation by plugging into this formula. And the reason I know this is the formula I want to plug into is because I'm not given a y-intercept. So I'm simply going to plug into y1, m, and x1. So here we go. Y minus 1 is equal to m, which is -2/3, times x minus -2. So I simply plugged in my x-coordinate, my y-coordinate, and my slope. Now we'll simplify a little bit by distributing. All right, I'm going to go ahead and make this minus and negative a plus. And then I'm going to distribute. That's going to give me -2/3 x. Now I'm going to do a little side work. What is -2/3 times 2 over 1? Well, that's -4/3. So when I distribute -2/3 times 2, that's -4/3. And then the last thing I need to do to both sides is add 1 to both sides. So I'm going to get y equals -2/3 x. I'm going to do some side work. What's -4/3 plus 1? Well, to add fractions, I need a common denominator, so I'll add 3/3. And -4/3 plus 3/3 is -1/3. So when I when I added 1 to -4/3, I got -1/3. That, my friends, is the equation of the perpendicular bisector of that line. And one thing that I always do is I graph it. So I know that it goes from this point, the slope is down 2 and over 3. And then you guys, when I graph it, I can see really easily if my y-intercept makes sense. And I had a y-intercept of -1/3. And look where this graph crosses that y-axis. It looks like it's pretty darn close to -1/3. And the last example, you guys, we're going to do really quickly because we're running out of time. It simply says the triangle ABC has vertices at -5, -1. 0, 4, and 4, 2. So I'm going to draw my triangle. And I want to write the equation of the altitude to side AC. Well, altitude goes from a vertex and is perpendicular to the opposite side. You'll notice that the slope of AC is 1/3. So my slope needs to be -3. We're out of time, but you'll see the answer.